Want to build the most efficient road system, internet network, or power grid with the least cost? You'll need something called a minimum spanning tree. And today, we're unlocking two legendary methods to build one, Kruskal and Prim algorithms. Stay tuned, you're about to understand them like never before. Welcome to EduAIverse, where we break down complex computer science concepts into simple, real-world ideas. Today, focus is on two famous algorithms used to find minimum spanning trees, Kruskal and Prim. We'll explain what they are, how they work, their differences, and where you might use each one. Let's begin. What is a minimum spanning tree? Quick recap. A minimum spanning tree, MST, connects all the nodes in a network with the least total cost. No cycles, no extra paths, just the shortest way to link everything. Kruskal's algorithm. Introduction. Kruskal's algorithm is a greedy method. It builds the MST by picking edges in ascending order of weight, making sure no cycles are formed. How Kruskal's algorithm works. Kruskal sort all edges by weight, lowest to highest. It adds the smallest edge to the MST if it doesn't create a cycle. It's repeat until all nodes are connected. The time complexity of Kruskal, 1 OE log E, where E is the number of edges. 2. Sorting edges is the most time-consuming part. When to use Kruskal's. 1. Works best with sparse graphs, few connections. 2. Easy to implement. Now Prim's algorithm. Introduction. Prim's algorithm also uses a greedy approach, but it grows the MST by starting from a single node and expanding outward. How Prim's algorithm works. 1. Start at any node. 2. From the current MST, choose the smallest edge that connects to a new node. 3. Repeat until all nodes are connected. The time complexity of Prim. 1. Using a priority queue and adjacency list, OE plus log V, where V is the number of vertices. 2. More efficient for dense graphs. Advantages of Prim's. 1. Great for dense graphs. 2. Can be faster with the right data structures. Disadvantages. 1. Slightly more complex to code than Kruskal's. 2. Needs more memory, priority queues. Conclusion. Both Kruskal's and Prim's algorithms are powerful tools for building MSTs, and knowing which one to use depends on your graph structure. Kruskal is simple and clean for sparse networks, while Prim shines in denser ones. Understanding them means you're one step closer to mastering graph algorithms, a must-know for data structures and real-world problem-solving. If this video helped you understand MSTs, hit that like button, drop a comment, and subscribe to EduAIverse for more simplified algorithm tutorials. Don't forget to tap the bell icon for updates on our upcoming videos. Thanks for watching, and keep learning smart.